In this video, we are going to see about the two-way finite automata. So before that, we will see what is variance of finite automata. Variance of finite automata are different models or extension of a basic deterministic finite automata. And these are designed to handle a broader range of computational problem or constraints. So it is classified into three types. One is finite state transducer, then two-way finite automata, and two-way tape finite automata. The finite state transducer is an extension of a finite automata that produces output along with processing the input. So it is widely used in the application like lexical analysis, natural language processing, and speech recognition. And next one is a two-way finite automata. In a two-way finite automata, the input head can move both the left and right. So it is also like a finite automata in which input head can move both the left and right over the input tape instead of only moving right side. Suppose for example, this is a tape. So if it is a tape and the tape head is here means it can able to move left as well as it can able to move the right. So it is two-way finite automata. And third one, two tape finite automata. Here, two tape finite automata is a machine that uses two input tapes. So each with its own read head, and transitions are based on the reading the symbol from both the tapes simultaneously. Okay. So the finite state transducers are device which gives the output for given input, where others are language acceptors. And example for finite state transducer is Moore machine and the Merle machine. So these are the two basic example for the finite state transducer. So Moore machine means output depend only on the current state. So each state has associated output. And in a Merle machine, output depend on the current state and the input symbol, generally more compact than the Moore machine. So all these variants are no more powerful than the DFA. In fact, they are equivalent to the DFA. So two-way finite automata. So two-way finite automata is a finite automata that allowed to reread its input. So the letterhead of the two-way finite automata allow both the left and right direction on the input tape. So the two-way DFA that can be mentioned as 2DFA. It is generalized version of a DFA which can revisit the characters already processed. So we can able to revisit the characters which is already processed. And the formally two-way DFA is defined as it contains the quintuples. Quintuple means it contains 5 tuples. That is, first one is a Q. So Q means it is a set of state. Then sigma is a input symbol. Then delta is a transition. Q naught is a initial state, and F is a set of final states. And when you are writing the transition, so if Q, the state into input symbol, it gives the state into L comma R. So L it indicates the left move or indicates the right move. So we have to specify which move we are going to do. And in a 2DFA, it can seen as only read-only Turing machine with no work tape, only read-only input tape. And this DFA and 2DFA recognize preciously the class of the regular language. The next one, this is a DFA. Next one is a NFA. The two-way non-deterministic finite automata may have multiple transition defined in the same configuration. So it has a multiple transition. And when you are checking the transition, when Q in the input symbol, it gives P of Q, that is a set of states, into, you have to specify the move, it is left or right. Like a standard one-way NFA, the two NFA accepts the string if at least one of the possible computational is accepted. If one of the possible computation is accepted means the string will be accepted in the 2NFA.